Ever since man became a thinking animal, what he really pondered was he alone in the universe? And it took thousands of years before his technology allowed him to make an experiment to find out. And I was lucky enough to be that very first experiment. I want to describe to you the labeled release experiment that went to Mars on the Viking mission to Mars in 1976 with a specific quest to look for life, extant life, stuff living as microbes in the soil of the red planet. Well, I'll tell you this as a classic experiment. A classic experiment works this way. First, you have a theory and you propose it. Then you design an experiment to test it, and you make a prediction of what that experiment will find. You send the experiment and see whether or not it finds what you think it will. If it does, you then duplicate it to verify it, make sure the first result was no accident. Then after you duplicate it, you replicate the whole thing from start to finish to be certain that you really got the right answer, or perhaps you didn't. Well, that's the route that I followed in the labeled release called LR experiment. It was a very simple experiment. It used a test for purity of drinking water used by public health authorities all over the world, still in use today, some 40 years after my experiment on Mars. And here's all you do. You take a sample of water that you suspect of being contaminated with microorganisms, put it in a test tube with nutrient, and incubate that test tube at an elevated temperature for 1 to 3 days, hoping that you will see tiny bubbles in the test tube. Those bubbles are the evidence that something is alive in the test tube, consuming the nutrient and producing gas from it. That was the simple experiment for Mars. What I did to soup it up, however, because there was danger that a spacecraft landed on Mars might not last very long, so I wanted to shorten the period, not have to wait 3 days, so I coupled it with radioactive carbon. The nutrients were trace labeled with carbon-14. Therefore, anything eating those nutrients would be eating the carbon-14 labeled molecules, and the gas they produce from it would be labeled with carbon-14, radioactive, and readily detected as the gas rose out of the nutrient. So this was the simple experiment, just an improvement on a regular test used for drinking water. But in addition, since we were going to Mars, where things could be different than Earth, I thought we should have a control. And I proposed a control. NASA agreed there must be a control, and it even designed it. The control worked like this. In the unlikely event that our experiment got a positive result, we would then take a separate sample of the same soil that produced a positive result, heat it to a temperature that would kill microorganisms that we know about, at any rate, but not so high as to kill or destroy chemicals, oxidant chemicals, which might have produced a false result by reacting with the nutrients. The temperature that NASA selected was 160 degrees centigrade, and we were to keep the control test soil at that temperature for 3 hours, let it cool, and then test it again in the LR instrument. Now, if the second time it was tested, the response was 0, or essentially 0, that meant that we had killed something that had made the first result, and therefore we had detected life. That was the confirmation we sought. On the other hand, If after heating the sample it still produced a response, then it was likely chemically induced and not biology. So those were the ground rules we started with. Well, we went to Mars. It took 9 months of holding our breath before we got there, and then tremendous tension on entry and safe landing. We landed safely at both spots, some 4,000 miles apart on Mars. We waited patiently until we could produce our first test. You remember the long sampling arm on Viking went out, pulled in a sample. It put the sample in a distribution box from which it fed various experiments. We were one of 3 life detection experiments that received soil samples. And on July the 30th, we had our soil sample and we squirted in this drop of nutrient, just a fraction of a drop, on a thimbleful of soil. And immediately, radioactive gas started coming out. We were astonished. We were very excited. We waited. We watched the gas continue to come out for the entire 7 days of the experiment. Then it was time to run the control. We really held our breath. We rolled in a fresh test chamber, loaded it with the soil, heated the soil to 160 degrees for 3 hours, let it cool, and squirted in that fraction of a drop of nutrient, and essentially nothing happened. Just a few counts per minute that were essentially background. Right then and there, we had satisfied the pre-mission agreed upon criteria for life. We could have said, we've detected life, hung our hats up, grabbed a bottle of champagne, and celebrated. But that was not to be. Finding life is such a sensational thing that even if you've previously agreed on the test, when it actually happens, you double think. And NASA and other scientists double thought. And they said, no, we still believe it's something else. And immediately they said, we think that on Mars, the ultraviolet light is much stronger than on Earth because there's such a thin atmosphere to absorb it. And we think the ultraviolet light hitting the soil activated it, and you took that sample in and tested it, and there were no microorganisms there. It was the activated soil that reacted with your radioactive nutrients to produce the radioactive gas. Well, that stopped us for a while, but my co-experimenter, Dr. Patricia Ann Stratt, who worked with me for 10 years and was essential in producing the instrument and transferring our science into the instrument that went to Mars, she and I said, wait a minute, we think we can test that theorem. So we called the engineering division at JPL and we said, can you control that arm to get it to go out and move a rock? And they said, we think we can. We said, well, let's do this. Just at dawn, move a rock and immediately take a sample from under that rock. That sample will not have seen ultraviolet light for hundreds of thousands or millions of years, and we'll test it. They said, we'll try and do it. And they did it. And we were able at dawn to move the rock, take the sample, and test it. And lo and behold, it was even a little more positive than the first one. So gone was the theory that our reaction was due to ultraviolet light. But then something very important happened. There was another experiment aboard Viking, which was not to look for life, but to identify the organic compounds that we all were certain was in the soil of Mars, just like on Earth. That organic matter comes falling in from space constantly and therefore is present and was present from the time the planets were first formed. We wanted to know what the organic matter was on Mars, so an instrument called a gas chromatograph mass spectrometer was sent to test the soil for organics and determine what they were. We were all astonished when it ran its test. It found no organic matter. Dilemma. We say we have life. They say there's no organic matter. NASA thought about that, and being conservative, as scientists should be, came down on the side of no life. There can't be life if there's no organic matter. The experimenter of the organic matter instrument said, well, you know, in order for us to detect organic matter in bacteria, we need at least 3 million bacteria per gram of sample. And that means in the tiny sample we take, we need at least the bodies or the living matter from 1 million bacteria. Well, the LR experiment was quite a bit more sensitive. We had demonstrated on Earth we could detect as few as 10 cells, 10 bacteria. So there's a 10,000-fold difference in sensitivity, and I suggested maybe both instruments are right. We detected sparse life, but the life wasn't dense enough for them to detect. That didn't ride. So the answer that was officially accepted was that there's some strange chemical in the soil of Mars that imitates life. That was 38 years ago. People have been proposing various chemicals to reproduce our results. They never have. Nothing has reproduced the results. But here is what really counted. The control, which in science classes you probably have learned is the most important part of an experiment. Our control was extended. First, we showed that the active agent in the soil could not survive 160 degrees. Next, we went and looked at heating it to only 50 degrees. What actually happened? The engineers managed to heat it to 51 degrees, and the signal that resulted was only 10% as large as the one that we got when we ran the active experiment. So here we would now have to have some chemical that is virtually destroyed at 51 degrees centigrade, and that's a very modest temperature for chemicals. We ran the experiment again to duplicate that, and we got a temperature this time of only 46 degrees. You can't quite precisely control it. At 46 degrees, we got a response that was 30% as high as the original response and looked the same. The shape of the curve was the same. It looked like it could be that there were microorganisms, many killed or damaged, so their metabolism was reduced. And that's very similar to what happens on Earth. When you want to distinguish E. coli bacteria from the whole group of coliform organisms, you heat the sample to 46 degrees, because at 46 degrees the E. coli survive, but the other coliform organisms do not. They survive at 37 degrees, but not at 46 degrees. Very similar situation that could be biologically explained on Mars. But something even further happened with the control. We tested a sample that had been stored in the distribution box for 2 months. And it had been active when it was first put in the distribution box. In the distribution box, the soil is maintained in the dark, isolated from its environment, and kept at a temperature at about 10 degrees C. On the planet, the temperature varies from maybe room temperature down to minus 50 degrees C at night, and of course there is light every day. Well, when we tested that sample that had been held in the dark at a constant temperature for 2 months, the result was 0. This was astonishing. What chemical just held in a box at 10 degrees for 2 months would lose all of its activity when it had been perfectly active when tested after it had been held for only 3 days? Well, as I said, in a typical experiment, you should duplicate the experiment. We duplicated the experiment at Viking 1, and we got the same result. So 2 times we showed the active soil responded, and we showed the controls were negative, even just letting the soil sit in the dark box for 2 months. The next was to replicate the experiment, and we did that 4,000 miles away at Viking 2. And lo and behold, we got a positive response, and we got negative controls, and we had therefore replicated the experiment. Even in one of the tests, which we thought was an active test, we had the sample held for 3 months in the distribution box. We took the test portion and we dosed it with 2 squirts of nutrient, thinking maybe that would produce a response. It did not. They were both negative. So in effect, that experiment turned out to be a control. At any rate, we ran 9 experiments on Mars, and all of them were either positives or negative controls, all confirming or consistent with the presence of life on Mars. In the 38 years since Viking, we've learned a lot about life on Earth and Mars. We used to think life occurred only in a frail, thin surface cover on Earth. We have since learned it exists in the most difficult environments on Earth. We can't find a place where there's no life, except perhaps in molten rocks and volcanoes. But deep under the sea, in the atmosphere, every place on the Earth, in frozen ice, we have found living microorganisms under conditions much worse than some on Mars. And recently, lichen and bacteria have been exposed to the naked space environment on the International Space Station for 1.5 years. 80% of them survived. So they would survive on Mars. And we also have learned that conditions on Mars are not as tough as we had thought. We have confirmed Viking's detection of liquid water in the soil of Mars. Curiosity confirmed 2+% moisture in the soil that it tested. That's more than twice the amount of moisture in the soil, the sands of Death Valley, which are teeming in microorganisms, which the LR detected out there. So we now know microorganisms are much more hardy than we suspected at the time of Viking. We know the environment on Mars is much more friendly than we thought at the time of Viking. And we have also learned that microorganisms could have been ejected from the Earth when meteors hit and gone off into space and traveled all the way to Mars, sometimes in as short a time as a year, sometimes perhaps taking thousands of years, but still remaining viable in frozen, dried state, such that landing on Mars, they would be rejuvenated and could take root and infect the planet. So we really don't know whether life on Mars came from Earth or whether Earth life came from Mars and we're really evolved Martians, or whether both of us came from some other planet, perhaps from panspermia, the theory that life is constantly traveling through space, infecting planets or other celestial bodies. Now, the astonishing thing, which I want to end with, is that in these 38 years since Viking produced positive results in the LR test, no other life detection experiments have been sent to Mars. NASA has forbidden the sending of life detection experiments. It has carefully explained that even Curiosity has no life detection capability. I don't know why that is. It has never been satisfactorily explained. It's a puzzle. When you find a result, even if it's suspicious, you should go back and elaborate it. And we have proposed a new elaboration of the LR experiment, which all the astrobiologists I've spoken to agree would settle the issue. It would test for left-handed and right-handedness of the organisms we believe we found on Mars. If there is a difference in their metabolism of right-handed amino acids versus left-handed amino acids, they all agree that would be proof of life. But that experiment has been repeatedly rejected by NASA. So I claim now to have taken over Curiosity and have made two predictions. One, I predicted it would find liquid water, which NASA until then has still been saying was not on Mars. That prediction has become true, and Curiosity has now stated it has detected 2+% moisture in the soil. And secondly, I predicted that it would find complex organic matter, solving the organic matter problem. For some reason, Curiosity has not yet run its complex organic matter experiment. It has an experiment that can extract organic matter with liquid and test it without heating it. It fears that heating it, as Viking's experiment did, looking for organics, will destroy the organics. But it has not yet performed the non-heated organic extraction experiment. And finally, the cameras that Curiosity carries include very sensitive high-resolution ones which could look up close at greenish spots on the rocks. Viking found greenish spots on the rocks. Curiosity has found greenish spots on the rocks. They should be examined close up to see if they look something like lichen, which they could be, or if they have any characteristic of living material. But that remains to be done. My prediction remains that they will use that high-resolution camera, and they will use the liquid extraction method to identify organic matter, and I predict they will find complex organic matter, removing any objection to the LR having detected living microorganisms on Mars. And I think that is going to happen pretty soon, and I believe it will reinvigorate the search for life on other planets.